Hello, everyone. I hope that you are hearing me wide and clear. Sorry for the delay, BrightTalk decided that it's the right moment for me to reset my password, so I had to go through that quickly. And we are going to start our presentation right away. So today we are going to talk about, multi-cloud deployment of MySQL in particular, and therefore, let me share the slide so that you can follow. Okay. I hope that you see that now. Okay. Can someone confirm that you are hearing me and seeing hopefully the slides? Okay. Okay, I will take that for yes. So let's get going. So today we are going to start by going quite into some level of details into MySQL as replication technologies. We are going then to speak about reference architecture for running multi-cloud deployment for MySQL. We will have then a demo or walkthrough, and we'll use our documentation to make sure that you are able to reproduce that at your place. And then we will talk about how you can make that actually yours, everything that you'll be seeing today. So MySQL is replication technology. So as you know, MySQL is quite mature technology with decades now, of experience and successful use in many sectors. And before going into the details of, MySQL replication, we need to have some common ground on how the replication is working. Therefore, this is a pretty much, an introduction just for you to have some, common understanding about the layers of MySQL. So we have at the top the connectors, which basically, the client database clients will connect to. So basically, it's the communication protocol, and then we will have some dispatching mechanism so that a thread will, MySQL at least, will handle your request and so on. Then you are going to parser your request, which is typically a SQL, like a query, but nowadays MySQL as well supports document database like, API. Then you will have the query optimizer that will do its best to figure out what is the best way to execute your query from like speed perspective. And execution engine. So the execution engine, once the query optimizer hands to it, like the steps to execute, it will be the one actually executing those steps by communicating with the storage engine. And unlike other databases, MySQL was built with pluggable storage, like architecture in mind, meaning that you can, like use different storage engines with different deployment of MySQL. InnoDB is by far the most used one, I think, but RocksDB and the old between quote legacy MySAM is probably the one to know. There are others, of course, if you go into the details of it, but we are going to focus on InnoDB today. And how this is related to replication, so we'll go into the details of that, but what we need to remember is that when we say MySQL Server is actually everything that comes before the storage engine layer, and the storage engine is basically what communicates with the actually storage, as the name implies, but as well with the memory structure. It has its own internal memory structures. And now we are going to talk about what happens actually when you request from MySQL and InnoDB to commit something. Why this is important? Because it will allow us to understand the different replication technology that we are going to talk about next. So, when you are trying to commit on transaction, typically you go through different stages. So the first stage is actually to prepare the commit. And at that stage, MySQL Server will issue actually this MySQL bin log prepare that will actually behind the scene in case of InnoDB engine, we call the InnoBase extra prepare. So all of those are actually functions that are called in the respective codes. And actually what the InnoDB engine will do is actually will flash all the changes. So when we say flash, it will persist all the changes to disk that have been, let's say, in flight so far in the transaction. And this is done by writing the change to a redo log file. Okay. Once that's done, it will send an acknowledgement back to the MySQL server, and then the next step for MySQL bin log will be to actually sync its own view of the changes that did happen in another file called bin log. And you might ask, okay, why you are doing it both? And I agree with you. This is an area that MySQL probably can simplify. But today, currently the current architecture of MySQL, those two files serve different purposes. So the redo log is a kind of physical view of the change that did happen in the database. Think about it like byte by byte copy of the changes that did happen during the transaction to your data files, for example. And the bin log is rather like more logical changes. So you will see the query that did happen and the state of the affected rows before that query. Yeah. So it's a way for MySQL to apply the changes and revert them. This is the best way probably to think about it. And when MySQL server will successfully write its changes to the bin log, he will issue a commit, message. So in case of InnoDB engine, this is handled by the InnoBase commit function. And the only thing that it will do is actually update the flag of the pages, because as you might already know, the database, most of the relational database and most of the modern databases, structure, the data into pages, or let's say records of pages. And it will basically update a flag on those already persisted pages in step 2 to say that now they are safely committed. It will then send an acknowledgement to the MySQL server, and MySQL server finally can happily, respond back to the client saying that, okay, everything was committed and it was successfully done. Okay. And for those who are familiar to two-phase commit protocol, you might, see that this is actually what's happening between MySQL server bin log and redo log. Behind the scene, it's pretty much two-phase commit protocol. Okay, but now what happens when we are replicating changes to other MySQL instances? Because that's what replication is about, is really replicating the changes between, two or more MySQL server instances. And if we look at the standard MySQL asynchronous replication, so this is basically the oldest and the probably most mature replication technology within MySQL ecosystem. So it's the same thing, okay, pretty much. The only difference is that, on top of, making sure that the redo logs and bin log are synced asynchronously, the primary, or what we call the source here, primary MySQL instance will send those bin log changes to the relay log, which is a file on the replica that hosts all the pending changes that were applied on the source, not yet on the replica. And when I say asynchronous, it means that the change, whatever action are happening on the replica, will not impact the course of the commit on the primary instance. There is another plugin called semi-synchronous replication, which is a kind of variant of the asynchronous replication mechanism, where basically the source of the primary server will only send a successful commit message or acknowledgement back to the client only if a configurable number of replica did receive the changes in the relay log. okay, even if they are not yet, like applied to the database, to the replica is database files, okay? And you can configure a number of things in the setups, like how many replica they need to acknowledge your changes, what is the timeout in order to be protected from long outages of or replica in your cases and so on. But we will not dwell into the details of that too much. The only point that I wanted to highlight is that there is this parameter which is called this way, missing source wait point, which defines actually when the synchronization with the replica will happen. And by default is after sync, which here means after sync to belong, meaning that the primary after syncing to the belong will make sure that at least the one or the configurable number of replica did receive the change, and only then he will issue actually the commit instruction to the InnoDB engine. There is as well another parameter or another value for that parameter, which is after commit, which I highly discourage because it might lead to perceived data loss. Why is that? Because in that, when the semi-sync source wait point is set to after commit, the replication to the replica, basically sending the changes to the relay log on the replica, will happen, as you see after basically step 7, which means that you might end up in a situation where the changes were applied locally and persisted. But if you have a problem like a crash of the primary server between step 7 and 8, the client that might connect to the newly elected primary, which was a replica, might see a data loss event. Please do not hesitate to ask questions in the chat. I will try my best to respond to them during the course of the session. And I know that some of those terms, or let's say order diagram, might be confusing, but hopefully you will be able to clarify those confusion if you have some of them. Okay, so now we talked about the classical replication technology of MySQL. A more modern one is what we call the group replication protocol, and it functions in a different way than the other ones. But I think to have a very good mental model of how it works, you need to remember the following: is that once you have actually a commit request on one of the instances, because in group replication you can actually have many primaries instead of single one, even if we recommend to always run your group replication cluster in single primary mode. But let's suppose that it's not the case, then you can receive actually a commit and an update on any of the members of the group replication cluster. And what it will try to do actually before committing or before acknowledging that change to the client is that it will first broadcast that change to all the members, okay? And it will make sure that there is the same order of basically changes that were received by all the members, meaning that the group replication membership protocol behind the scene will make sure that all the changes happens in a sequential way from the point of view of all the members. And that's what the certification phase is about, is to make sure that there are no, let's say, differences in the ordering of transaction from the point of view of all the members, at least a majority of them, okay? And if that's the case, then they can continue actually independently, continue basically their course of action by applying the change to the log, the logs behind the scene, committing and sending back to the clients. Yeah. So if we go a bit in more details of the group replication protocol, and I think what you need to remember is the following. Yeah. first, this group replication plugins offers a number of functionality to the MySQL Server, the core engine of MySQL Server. So first of all is the membership, protocol, meaning that it will allow a number of MySQL Server to join an existing cluster, and as well fault tolerance, meaning that if one of the instance is no longer reachable from the point of view of a majority, then it will try to remove it from the cluster. It allows as well, to perform leader election if a problem, happens to the leader. It allows as well, as I said, to establish like a total ordering of the transaction. And that's it basically, yeah. And behind the scene, it's Paxos, implementation. You can think of it as another alternative to Raft protocol, which is probably more popular nowadays. And MySQL, developers recently did invest on, let's say, tooling to help everyone, create more easily InnoDB cluster specifically. And we have like two variants. The first one is what they call InnoDB cluster, okay? And basically InnoDB cluster is group replication plus MySQL router, which is a database proxy provided by, built in or provided by the MySQL developer. I'm saying this because actually you can have database proxy that are outside of the MySQL ecosystem itself, like Proxy SQL, but this one is really provided by the same developer and it's integrated with the group replication in this case, and in InnoDB replica set. And it allows you to transparently, always target the correct, primary and read-only replica if that's what you would like to do. And there is as well this MySQL shell, which is basically a tool to administer your, InnoDB cluster. Replica set, so as you can see, it's exactly the same than what you see in the InnoDB cluster, apart from the fact, which is a big change, is that it's not based on the group replication, it's based on asynchronous replication, as I tried to highlight in red here. So it's not group replication, it's rather asynchronous replication. And that has a number of implications, meaning that, for example, there is no automatic failover between your primary and asynchronously replicated replica. Okay, so this is something very important to remember. You might ask then why, bother with InnoDB replica set, because, there is MySQL router in the picture. The MySQL shell as well allows you very easily to administer the InnoDB replica set. The only thing that you need actually to figure out yourself is the mostly the automatic failover, which there are tools that can help you with that, like Orchestrator, if you don't know that tool. And there is as well another technology that you need to be aware of, which is InnoDB ClusterSet. So I know the name might be confusing because there is cluster in every and set in all of them, or at least in 2 out of 3 of them. But what you need to remember is the following: that InnoDB ClusterSet is a technology that allows you to have disaster recovery based on a number of InnoDB clusters, so group replication cluster that are independent, from between each other, meaning that actually you can think of it as running 2 or more InnoDB clusters. And on top of it, you have an async replication layer between the primary of every InnoDB cluster. That's what you need to remember. And for me, this is by far today your best bet when trying to run, like disaster recovery solution or multi-cloud setups, as we are trying to talk today. So now we are going to move to the reference architecture for multi-cloud deployment, how you should go about it in our opinion. And let's try to, to go into some details of that. So first of all, here you see 2 clouds. So Cloud 1, Region 1, and Cloud 2, Region 2. By the way, this would apply as well to disaster recovery, ready deployment in the same cloud, meaning that you can as well think about cloud 2, region 2 as another region of the same cloud 1. Okay, so it serves the service architecture, so it's multi-cloud deployment, but as well multi-region deployment in the same cloud for disaster recovery purposes. And obviously, as I said, we recommend using cluster sets, which basically means that we have independent InnoDB clusters here, one per region, and async replication between InnoDB clusters. Okay, and what you see here as well is that we recommend having the MySQL router embedded in your application, at least to have one per server if you are using servers. By the way, whatever you are going to see later on in the demo works for VM-based deployment and Kubernetes deployment, including the the situation when you are using the Kubernetes managed service of the cloud provider. You can as well run your own Kubernetes if you wish in your own private data center and have it replicated to another like public cloud. This would work as well. Yeah, so getting back to this reference architecture, obviously, as you see here, because ClusterSet, the minimum recommended, or the minimum actually that you need to have in order to have automatic failover is 3 nodes. That's why we think that you need to have at least 3 instances in your primary cloud, and you can have in your cloud 2, region 2, or on your region 2, more generally speaking, you can have one, InnoDB cluster would work with one, but you lose, let's say, all the, automatic failover associated to group replication. But for cost consideration, you might consider that. And that's it, yeah. And the other thing that I wanted to talk about a bit briefly is that in this situation, unless you have the mandate to run all your primary application in one region, it's important to try to balance a bit your footprint by interleaving basically your primary InnoDB cluster, on both sides or on both regions in this case. Okay, because otherwise you will end up by very beefy region that has, let's say, full deployment of MySQL, so 3 instances, and another region with only mainly 1 instance, so very reduced footprint, and therefore when the day comes when you need actually to switch over, you might run into all sorts of issue when you are trying to scale your standby, let's call them clusters, from 1 to 3 or more. Yeah, so I think this is a much better setup if you cannot afford to have like 3 instances everywhere. And by everywhere, I mean in both regions. Okay, so some more general recommendation. As I said already, I think it's a mandate to run your main region with a minimum of 3 instances. Why is that? Because it's always easier to recover within the same region than actually across regions. Because here we are talking only about databases, but remember that you need to orchestrate in case of a failover to another region. You need to orchestrate the switch with all the applications that are connected to your databases. So it's not as easy as doing it only at the database side. You need to leverage the cloud isolation constraint to improve your overall high availability constraint. So meaning that you need to use availability zones. If you cannot use availability zones, then you can probably try to use other mechanisms like availability sets in Azure, or the equivalent, okay, not really equivalent, but similar, construct in Amazon and Google, where basically you can, within the same availability zone, ensure more or less that your nodes do not end up in the same server, or even better, do not end up in the same rack. Another important factor or important consideration to keep in mind that is not written here is that MySQL group replication is quite sensitive to latency. So it's important as well, if you are not happy with the resulting throughput, to leverage some like proximity placement group or similar mechanism so that your instances end up, let's say, being close from let's say latency perspective, while ensuring that they are not running the same node, because if they run the same node, it means that you don't have actually a shared node. I think as well that it is a good idea to have at least one secondary region with a symmetrical setup to the main region. So basically having 3 instances at least on one side and the same number of instances on another region, to make sure that when actually you need to switch to the DR region, you don't need to do a lot of post-processing in order to have a fully working setup. I mean, if you did a bit of database operation, you know that one thing that you don't want really to do is to do a lot of tasks when actually you are trying to manage a failure, and in this case, a big failure because we are talking about a complete region outage. I already talked about interleaving primary and ODB cluster across regions. And one last thing is to keep your backups local to your region. So you need actually to have local backups that are run on your InnoDB clusters in every region, and not try to actually copy backups across regions. Okay, the demo time. So just for the prerequisite, and then we will move actually to our documentation, and I will explain, how you should read it and what to look for there. So first of all is to create a small demo environment. So here using LXC, you are executing a VM. Here I'm assuming that you are using Ubuntu machine, but it should work with any other Linux distribution. Here we are assigning 4 CPUs, 16 gig and 32 gig of, let's say, storage. I think if you are low in, let's say, resources in your laptop, because this is meant to run fully in your laptop as a simulation, as a demo, you can probably put 12 gig and even, let's say, a bit less than 32 gig, probably like 20 gig of storage, and it should still work, assuming that you don't run like 3 instances in both like models. Yeah. Okay, so here as well we install Juju, our orchestrator. So you can think about Juju as the backbone of our operator framework, meaning that what we are going to use in order to do this is an operator. But unlike Kubernetes operator that only works on top of Kubernetes, Juju allows us to actually have operators that work with VMs, Kubernetes, and even the different cloud provider like Amazon, Azure, and Google Cloud. And basically, we will manage their VM layer if we like EC2, for example. So this is what I think sets Juju apart. Another thing that we will talk about it in Juju is its ability to integrate, programmatically different workloads together or wire them together. We will see that in a bit. This is just to make sure that Juju is able, to be installed. And here we are using micro-K test, to serve as a local cloud or local Kubernetes installation. So all of this is just to make sure that we have all the services running, and that's it. And then the last step would be to Juju Bootstrap micro-K test micro. We have as well pretty much all of this in our documentation, but I wanted to show it to you here because in the next section where we are going to talk about what we call async replication or cluster-to-cluster replication, in the documentation. By the way, you can scan this QR code and it will, move you there where we are going to continue this demo. So this is basically where we will continue, deploying databases and so on. Yeah. So let me switch to that. Okay. So I stopped sharing because I'm switching screen. So give me one moment, please, to find back my link. Okay. Okay. Sharing again. I hope that you see actually the documentation page. Okay, I take that for yes. Okay, I see already some questions. Someone is saying that he's unable to see the screen. Is that correct, actually? Okay, I think now it should be resolved. But for the first question, the question was, is it the same for public cloud Azure only for VMware deployment? So just to say that this should work, in a variety of configuration. And let me show you this. So today we are, calling this, like a feature cross-regional async replication or cluster-to-cluster replication, as we'll name it quickly. And to respond to the question that was asked, so actually we support, a number of configuration. As we speak, those are the clouds that we are supporting, okay? And we continue to validate the different combination. Okay, so for example, we know that it can work, between Azure and Amazon, between your private cloud and your cloud and your those public clouds. And with every release, we try to test more, configuration, support more configuration until you, basically update the documentation accordingly. So that's why I wanted to share with you the documentation, because even if today a given setup might not work, eventually you will have all the clouds that are provided by Juju supported, and you can take Juju supported clouds to see the list, the full list of clouds that is supported by Juju from deployment perspective. So now we will continue with the workthrough. So in this case, we are creating basically a first cluster that we are calling Rome, and second one that we are calling Lisbon. Then we are switching, to Rome, deploying MySQL KTest database 1. Okay. And here we are choosing the edge channel. Obviously, if you are going to play this in your customer-facing environment, that you need to use this stable one. Config profile testing. So I recommend to keep this for your own laptop, like when you are playing in your laptop, because it will reduce the resources consumed. But obviously, if you are running in production, then you should, remove that, which will default to config profile production, and it will more aggressively reclaim all the resources that you are allocating to it or that are available in your VM in our case. And he's just giving the cluster some nice names so that we can refer to them later. And we are doing the same thing to Lisbon, deploying another database. Then here we are going actually to wire the two models. By the way, this is when we say model, it means simply Kubernetes namespace. Okay. So we are switching back to Rome, and we are offering basically this service. You can think about it as an endpoint from DB1 that we call replication offer. And then we are doing the same thing in Lisbon by offering this endpoint of DB2 replication offer and naming it again replication offer. Okay. And in order to finish the wiring, so the first step is to expose the endpoint. The second step is actually to consume the endpoint. Here we are switching to Lisbon, and we are consuming actually Rome's replication offer. So meaning that DB2 deployed in Lisbon will now be able actually to read from Rome. And then we will integrate actually the replication offer that was just consumed to the DB2 replication. Okay, and this is basically meaning that now database 2 that is deployed in Lisbon, which is behind the scene. I probably did not mention that because it was obvious, but behind the scene what we are using is basically ClusterSet and group replication. And once this is done, you will see that as we are putting here, cluster ROM will get into block state waiting for the replication to be created, because so far we didn't actually create a replication. We just made sure that both namespaces are able to communicate. And once you create the replication, okay, the cluster will go to green basically, and you will have basically two at this stage, at this moment, two instances or two group replication cluster with one instance each, in one in Rome, one in Lisbon. If you would like ever to move back, so let's say that there is a problem in your primary, let's say Rome, and you switch to Lisbon, okay, so you do the switch to Lisbon, and then you would like to go back, then you need actually to do the wiring on the other way. In this case, you just need to do this, okay? You switch to Rome and you make sure that basically ROM database can read, the stream coming from Lisbon. Okay, you can as well run this command to see that everything is fine or no. And this is the example. You see basically in Lisbon that is playing the role of replica, meaning that's not the primary cluster, and ROM being the primary. Okay, and you see actually the 8 points that are here. And as we said, because we recommend to run 3, per instance, then you can actually do Juju scale application, like DB1 and DB2, and you provide the target number of instance 3, and you specify actually the namespace, and it should work. Okay, and basically that's it in order to have a running cluster. Okay. So this is basically, in order to even play more, okay, what you can do. So this is what we already did, yeah. We can deploy actually MySQL router Kubernetes, okay, and this is a MySQL test app. So just probably a few words for you to follow. So actually what happens behind the scene when you put Juju deploy MySQL test app or Juju deploy MySQL router k-test, what Juju will be doing is actually downloading the operator, so the logic, the automation that we build around those components. So MySQL router k-test, with no surprise, it is actually handling MySQL router for Kubernetes as a workload, and just MySQL k-test is the operator handling for Kubernetes the MySQL server itself. Okay. And this is what I called, one of the added value of Juju that sets it apart from the competition is this capacity to wire things together by actually encoding those integration layer within the charms themselves, within the operator themselves. So just what you need to do, for example, is to relate MySQL test app to MySQL router, and automatically MySQL test app will actually be able to talk to MySQL router. Same thing we need as well to, as I said, make sure that MySQL router Kubernetes is able to connect to the database, in this case, database 1. And of course, we know that for your case, probably your application will be running outside of Juju. So that's why we have a section, what we call external Juju clients, to say that we support as well having clients that are running outside of the Juju ecosystem, so you can keep Juju only to run your workloads, like your operator for MySQL database in this case. But as you might have guessed, we actually support as well other databases. And you can pretty much do the same by using the data integrator that will allow you actually to get credentials that you can use from outside Juju and talk to the database going through the MySQL router into Juju. Okay, and this, as you might have noticed, follows the recommendation that we made in placing MySQL router as close as possible to your clients. this is just to show quickly, how a switchover, look like. So this is basically the command that you need to run. So you run it basically on the target cluster that you would like to be promoted to primary, and you just need to say, okay, promote to primary, okay? And if everything is fine, meaning if all the pre-checks that you are doing, are successful, then this should work. If you are really in a situation where you lose all connectivity and most probably, most of the checks will fail, you can still force that, okay? So you can just add force true. I mean, it's as simple as that to say, okay, I don't care what is the situation of my old primary cluster because I lost it or something bad really happened. I just would like, to make sure that I can, run now my application with this, standby cluster. And by doing that, okay, we will do a number of things, but most importantly, we'll promote this, cluster set to primary, and you will make sure that the old, cluster is not connected anymore to the, remaining cluster. And recovery, so basically you can do as well the reverse. You can, I mean, if you did things without forcing, you can go back to the previous primary, okay? So I'll stop here for the sake of time because I would like as well to cover a few more points, but few words before moving back. So as you might have noticed it, so in this very simple actually setup, we are assuming that actually you have the same Juju controller between your primary region and your, standby region, which is of course not a production setup, meaning that in a real production setup, you need to have two Juju controllers, okay, that are communicating between each other, but they are split, so one per region. Therefore, two Kubernetes as well, one per region, and so on and so forth. And we are assuming as well that you did all the work that you need to do in order to have connectivity between the two regions. We have actually, we are working on documenting that as well, so you might hopefully see it. But this is highly dependent on your, so we will document just one way of doing it, but it highly depends on how you are doing the connectivity between your private cloud and the other cloud or between two clouds. So it is just an example, whatever you will be seeing on the documentation. Yeah. So I want to just highlight this. It's not what we are simulating here is a rather simple case where basically you can have probably this setup in very two close region in the same, cloud, like for DR purposes. But for multi-cloud, you definitely need to have different Kubernetes cluster. You need to have different user controllers, and you need to, let's say, figure out the connectivity part. I mean, we have already like a playbook on how to do that, but just going through the playbook probably can take like something like 2 hours to explain everything. We might, I mean, we'll be doing that in documentation, but probably we'll do another video just to go through all the steps and explain what's happening. So let me get back to the slides now, because I still would like to show you a few things. And again, don't hesitate to ask questions if you have some. Okay. 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 Well, I hope that you are still seeing me. Please shout out if it's not the case, but it seems to be working. And what I want as well to take the opportunity, of this webinar to tell you that actually our solution. So what you just saw basically, in the previous instruction, what we call Sharon MySQL, which is basically an operator for MySQL that works not only for Kubernetes, but as well for VMs, is now GA, and is something that is already, chosen and, by different customers, different canonical customers, something that we are pretty much confident with. And you can check this link to see all the benefits that you will have by opting for this Sharon MySQL. That being said, it is completely free. You can, test it yourself, as we did see, in the documentation. There is no paywall or whatsoever, so you can test that yourself. And if you like what you see, you can therefore make it your own, as you will see. So if you are an enterprise setup and you need to get support and security fixes, not only for the operator, but as well for MySQL server, and as well, all the tooling that we are using behind the scene, to offer the stack, because we didn't, get time to go into details of that, but we are not only using MySQL group replication, we are using extra backup for backups. We have as well our own Prometheus exporter for, to monitor your MySQL installation fleet, and so on and so forth. And the security maintenance cover all of that actually. So everything that you'll be getting from us, it will have a security maintenance for up to 10 years, commitment for up to 10 years from the moment it is released in a given Ubuntu release. Meaning, let's say in next Ubuntu release, LTS will be 20, or whatever the next one will be. Let's say it is 2604. Have, let's say, MySQL 8.4 or more recent by then. Then this will be supported for 10 years from that moment. Okay. So for example, if you take the current, MySQL that is shipped in 2404, it will be, supported until 2034, which is a good amount of time. You will as well have, hardened configurations, from our side, and the hardened configuration does cover the operating system and the database as well. Okay. So to help you, comply with whatever security standards or regime you might be, subject to, like PCI DSS or HIPAA or whatever regime you might be, subject to. As I said, we offer as well support with different, setups or options to choose from. So we have phone and ticket support, either 24/5 or 24/7, with some SLA on the response time. We have as well what you call firefighting support with screen sharing, meaning that you have one of our experts that will jump with your teams and yourself into the issue and help you investigate by, together, you and our expert, let's say, guiding you through the process of diagnosis and investigation and hopefully fixing the issue. We have as well some what we call managed services, where we can manage some of your infrastructure on your behalf. So as I said, we can manage some of your MySQL infrastructure on your behalf if that's what you need. And we have as well some consultancy offerings, so workshop if you are starting your journey with MySQL, or if you are wondering how to better meet some of your service level agreements, we can have a workshop either on site or by video conference, where we go over your points and try to, at the end of the workshop, provide you with a design document that help you, let's say, solve whatever problem you have. We can as well help you deploy, either proof of concept or working solution if you would like to assess an idea or a new architecture of deployment. We have as well some upskilling, offering to help you ramp up on MySQL, and as well the tools that you did see, like Juju and so on, if you choose to go that path. Something else that is, I think, can be interesting for many people. So if what you need is actually a Docker image that has, some specific tools within it, so apart from what we talked about, like MySQL Server, the backup tools, and Prometheus exporter, if you need for more than that, for whatever reason, you might be in need for some specific packages that are not currently covered by the standard Ubuntu offering, then it's something as well that we can do. Okay, we will analyze the dependencies. So when we say dependency, meaning, all the tree of dependency, not only like the first level of dependency, and you make sure that if there is a problem within any of those level of dependency, we will provide provide a security fix for those. And this as well for 12 years. So it's not only 10, as we did see previously, it's 10 plus 2. Okay. So that's basically, I think, it for today. We have some time for questions. So if you have any question, any clarification request, I will be happy to try to answer them. Okay, let me probably stop sharing and check if we have any pending questions. Okay. Okay, thank you, Robert, for confirming. Yeah, I see. I mean, all the questions that I see were, let's say, responded to. So guys, if you don't have anything else, I think we can stop here. So thanks for joining. Wish you a good day ahead or whatever time you are in, and see you next time. Have a good day. Bye.